Hi, my name is Juan Cardona and I'm a data product manager. So what I'm going to do today is I will do like really simple exercise. So basically we're going to do like a simple project in Google Colab, and then we are going to uh, do to create a Python project that is going to give us as a result a web page like this one, where any user can use that predictor. So basically, the train model here, what it does is like you can give it like ages, a string, a list of ages like 2, 5, 15.3, and 18, and it's going to give you back as an output the height. That's what that was the model that I we train or we are going to train for this exercise. If I click here submit, it's going to give us something like this. So you can see like when the age is 2, the height is 33.96 in inches. When is 15.3 is 60.58, and when the age is 18, the height in inches is 65.98. So basically we're going to do again a little exercise that is going to help us to put right for production whenever or whatever more complex machine learning model we build in the future. So here we go. Okay, first of all, we are going to import this. These are like the packages and libraries that we're going to use in order to put this to work. Um, Pandas, NumPy, sklearn, Plotly. We're gonna use Express in order to do the graphics, and the last one, which is Orca, is going to help us to manage the pictures, because this one here that you see here, they are just pictures. So basically we're going to run our project in the back, and at the end is going to give us a picture that is what we are going to show in the web page at the end. So let's check if it's ready. Okay, it's ready to run, and let's continue. Okay, now with this one here, uh, the thing that we're gonna do with we get is get the data which is in this URL, and we're going to download it into our project, which we can see here that we have the data there. In order to see our data, we can do something like data is equal to pandas dot read, but we're gonna put here like pickle, this one here, and then we're going to select our data. Let's copy here the path, and we're going to take this, and let's show the data. Okay, here we can realize here that our data is just 100 rows and 2 columns, age and height. So basically we're gonna train a model that is going to let us know what is the age. That's going to be the variable that we're going to predict based on the age. That's going to be our x basically. So if we want to do something here, we can ages is going to be the data, and we're going to use our age variable, and height, sorry about that, height is going to be data, but we're going to have the column height, right? Okay, so if we want, like for example, have an histogram, a histogram of ages, we can do this histogram, and in here we can realize that that it's giving us negative values, which is impossible because in ages you are not going to have negative values. So we're going to kind of clean up a little bit so we can have more accurate data. So in order to do that, we're going to say again that our data is going to be equal to the same data, but we're going to select the ages that are positive, and then we are going to define again ages and height based in the new data. So if we do ages histogram, so we can notice now that in this new histogram we don't have negative values, so we are good to go. Okay, in here we're going to graphic our data so far. So we are going to use plot, then scatter, here we go, then we're going to get x parameters, which is going to be ages, and then our y field is going to be height. So age and height. So something happened here. Okay, here is saying that key error in height is because it's a typo here. So let's see if it's working. Okay, so we have this is the points of the data that we have so far. Okay, so now that we have this graph here, let's do something. Figma px, this px is what we have here at the beginning, broadly expressed. So we're going to use that broadly express, and we're going to use scatter. So in x we're going to have ages, and in y we're going to have height. It's here we have height. We're going to create a title. It's going to be equal to height versus age of people, and then we're going to have some labels here. These labels are going to be in a way of dictionaries. So we're gonna have like x, which is gonna be h in years, and another one that we're gonna have is y, that is gonna be the height, and this is gonna be in inches. Inches. Alright, let's run this one and see. Oh, let's show the graph here. Alright, so we have a better graph right now. Okay, now before training our model, so we're going to our data edges, we're gonna take it in a numpy array way. So we're gonna have edges to numpy. So, and we're gonna do the same with height numpy is gonna be equal to height to numpy, and let's run edges numpy and see what we got here. Okay, so we have this one here. Let's check the shape. Okay, it's 93. Okay, so let's reshape this one. So what we're trying to do is like trying to get all set up for our model. So edges reshape gonna be edges numpy, and let's reshape it. And how well we want to reshape it? Let's reshape it within count edges length and one here, and let's see how that looks like. All right, so we have how we shape edges data in way of array. That's what we're going to use in order to train our model. So in order to create our model or train our model, we're going to do this here. Model, we're going to use linear regression, which is here, and then we're gonna make it to fit, yeah, the x is gonna be equal to edges numpy reshape. Okay, here we go, and then the whites is gonna be equal to height numpy, which is this one here. The predictions is gonna be equal to model predict and oh, hold on. Let's test something here really quick in order to see if everything is alright. Okay, this is an error here, and the error is telling me one position requirement. Okay, in this error here, it looks like a typo again. Now I have the model. So if we want to get model coef here in order to check something, so the model coef is 2. So basically what this means is like for every unit that I increase on my x is going to increase 2.0014 in my y, that in this case is the height, yeah. Okay, so now let's going to give a graph of our model, which is x new. Let's so we're going to run our model from 0 to 19 and see what. It's going to be from 0 to 19. We're going to try to run our model in order to do like this, to simulate this pattern here. So that's why I'm going to use from 0 here to 19. It's going to be all right. So in here we're going to get it all right. It's going to be a list, and it's going to be a range. We want it to go until 19, and as always we have to reshape this. It's going to be okay. So the predictions are going to be equal to model, which is the model that we have above. Predict, here we go. We want to predict x new, alright, and we're going to get our graph using Potl Express again, px scatter, and we're going to, let's see if I can just, so it's going to be something like this here. Let's copy and paste this one here so we can save some time here. So it's gonna be scatter h, so height. Okay, this is the one that we already have, and then we're going to add our model. In order to do that, we're going to use fig add trace. Here we go, add trace, go scatter. This goes, we already defined it in here also, is polygraph objects as go. Yeah, so go scatters, our x is gonna be equal to x new shape 19, and then our y's is gonna be equal to breadth. The mode we want here is gonna be lines, and the name is gonna be, let's put model. Alright, let's run this thing and see what will happen. here module object is not callable. Alright, looks like I have another typo here. The S is gonna be capital S, and then we have our model over here. So far so good. Now that we have our model ready, let's download our model. So for that we're going to use joblib. From joblib import dump and load. So we do that, and then let's say dump model, and we are going to save this. We're going to save our model like this: model joblib. Let's see. Okay, we have our model ready here. In here we can notice that now we have our model here. Let's do like a really test really quick here in order to see that everything is okay. Model in is going to be a load of model dot joblib, right? And let's do the test here. Model in predicts. Let's select a random like age, so our model can predict, let's say 9, and see what happens here. Again, another error here. Okay, it's telling me that we don't have this model here, and it's alright because this one have to go. Okay, it's telling us that for 9 the height is gonna be 47.97. So let's see here. 9 is gonna be something like here. Yeah, it's close, 48. So in here is 47.97. So yeah, our model is working good so far. Okay, now what we're gonna do, we're going to make a function that is going to generate that picture. That we're gonna call it picture, make picture, and we're going to pass, in order this function to work, the training data file name. Then we're gonna pass the model, then we're gonna pass the new input. Let's call it new input numpy in a right way, and the output file name. So okay, first of all what we're gonna do is like load the data. So for this we're gonna use this with open training data file name RB. That's how we're going to identify, and we're gonna make it as F. Okay, then we're gonna have here like data is gonna be equal two pandas with pickle, the thing we did before. It's gonna be of f because it's our training data file name basically. So here we are defining like our data. So ages is gonna be data. It's gonna be the data that is in age, because remember that in here we are doing everything from the beginning. So, and remember that we have some negative, so we have to define again data that gives us just the positive. So when ages uh, is greater than 0, and then we define ages again here. So it's gonna be from data, but this data we already took out like the negative values, age, and height. Height is gonna be equal to data height. Alright, so far let's check if we have some input. Alright, so it's new. This is gonna be like the straight line, which is gonna be numpy array, and we're gonna select list. It's gonna be a list from range 19 because we have like the whole line in our model, and as always we have to reshape 19 because we have 19 values and 1 here. We have our predictions. This is going to be our model. This model is the one that we're going to get here. When we call this function, we have to, as an input, we have to add that model, and this model is going to predict x new. So far we are just having this graph here, and we're going to do our graph, which is going to be fig plot express scatter, and we are going to have an x ages. In y we are gonna have height, and we're gonna have a title which is gonna have height versus, or I would say like age versus let's put it like height versus ages. It's gonna be ages versus height. Alright, we have some labels. Again, a directory. It's gonna be x age in years, and we're gonna have another one which is gonna be our y, and this is gonna be equal to a in inches. Alright, so far so Now we're going to add the graph for the model results like we did above. Gonna be a trace, a trace, and then go scatter. Our x is gonna be equal to, again, x new, but we have to do the reshape as always. It's gonna be 19, and the y is gonna be breadth, mode, we have lines, and again the name is gonna be model. Alright, okay, so new breadth is gonna be what our model predicts, of course. Model predict, and the model is going to predict based in this new input numpy array. Because that's what we have, that's what we want our model to predict. All right. Okay, so now we're going to add, like, we have the general points, we have the straight line, which is our model. Now we're going to graph the points like the model is going to predict. So for that we're going to add again a trace, and we're going to use go dot scatter again. So this time our x is going to be the new input. Our x right here is going to be this new input array. Here, actually this one, go after this thing here. Okay, so our x is going to be our new input numpy array, and we have to reshape this one here, and we're going to reshape it in based on its original length. So new input. Okay, so now that we have that, 1, 2, okay, so y is going to be the new breadth, and then we're going to have name. Let's put new output, okay, the name is gonna be new output, mode, we're gonna have makers, because we're gonna mark those points in a particular way. I already have a configuration here that work really good, and those makers are gonna be like this: marker equal, so dictionary, and then we have color, we're gonna select purple, size. Let's get those dots in 20 in size, and then the line is going to be also a dictionary, and then we are going to do a color purple, and the width for that line is gonna be 2. Okay, here it's giving us an error, so it's because I got this here. Alright, so we must be good to go right now. Okay, it's showing this error here, but because we have invalid index here, syntax, invalid syntax, because have to be lined up with the rest. All right, so let's continue with this. So and also we want that every time we run this function, we want to save that file in our files folder. So for that, we're going to fig write image, yeah, because it's an image, and then we're going to use output file name. That is something that we have to pass here. That's the name of the file, and we're going to put the width here. That is going to be 800, and we're going to do show this graph. All right, I think we're good to go here. So let's try it. So make picture is our function, right? Make picture, and then we have to pass the training data file name, which is this one. Also, we have to pass our model, which is model in, is the one that we define here, model in, our model. Then we have also to pass the new input in a right way, so we can put numpy. We can put numpy because this one have to be, it can be in a string, so it's gonna be numpy array, and then the values that we're going to pass, which are gonna be, we can try 1, then 2, then 17. Okay, and also we have to output file name. Let's call it first pick, and remember that this one has to be in CVG format, so we can put like first pick dot svg. Let's see what happened here. Okay, so we have our first graph. So basically it's saying like for the input, the age of 1, we have 31.96. For 2 we have 33.96, and then for 17 we have 63.98. So far so good. So As we notice, we have to give it the information like the new input in numpy array ways. But like from the beginning, we want this exercise to be used for a normal person. So basically, that person what is going to get is normal numbers, and sometimes these numbers going are are not going to be even numbers. So we have to develop like kind of a filter for that. So we're going to define another function where we're going to do that. Basically, this function is going to transform whatever string we have into numpy arrays. So floats strings to numpy array. That's gonna be the name, and it's going to receive, or we're going to pass float string, right? Okay, so basically, in order to do that, let's create a little. We are going to like put another function inside this one, because we want this function to let us know if um, if the float is if the float of the string is true or not, like is true or is false, in order to like in order to see if we can use it as a number. Like for example, if user tried to pass an empty string or a letter, that's not going to be a number. So we have to create a mechanism in order to avoid that situation. So we're going to define here another function that is going to let us know if it's float or not. And we're going to pass the string here, a string, right? So it's going to try it, and it's going to check if it floats or not. So if this is true, it's going to return true, right? But then it's going to have an exception. So if it's not true, that means that it's false. It's going to return false, right? And then, so this little one, this function inside our bigger function is just to determine is it float or not. And then we're gonna have floats here, and we are going to say that converting numpy array to floats. So it's gonna be float x, right? So we're gonna say like for x in float string, that is what we're going to pass at the beginning, and we're going to split this by commas. So if float, which is the function that we have inside, give us that number in a numpy array. So basically what we are doing in this function is like we're going to receive a string, a list of numbers in a string way, and then this function is going to detect what is float and what is not, in order not to have like blank spots in our model. And it's going to return, of course it's going to return the floats. Like always, we have to reshape, and the reshape is going to be the length of itself, and then the one. This is what we need whenever we are going to use our model. Let's run this. So we're gonna have an example here, like let's call this function and see if it's working or not. Like, okay, this is the function, and I'm going to pass like strings, like a string of numbers, like 1, 3.5. Here we're gonna go like this, 4, and then here I'm going to go blank, and then here I'm gonna put 5.6. So you see, so basically the function check out of these strings, separate by commas, what are numbers. So I got 1, 3.5. Look that there is a lot of space, then a 4. The function did the identification as false. This one that is a blank spot, it didn't count of that, and then 5.6. So we are good to go here. Now let's take our function here. Let's test it. So if I have this one here, I might paste it here. So make a picture. So training data file name is gonna be this one that we have here, right? The one that we always use. Okay, then we have our model, which is model in. Then we have the input. Let's try this one that we got here. Alright, and then the output file name, let's put whatever name we want. Let's put any name, and we can always remember that we have to do it in SVG format. Alright, so we have 1, which is this one. We have 3.5, which the prediction is 3696, and we have this one, which is our last one, which is 5.6 dot 5.6, and the prediction is 41.169. So we are almost finished in our Google Colab file. So just one more thing, like now that we're going to develop our project in Python, so as you see here, we have like one image here and another image after we have the prediction. So we are going to use one image for that. So we want to save this image, which is the image with all the prediction, like just the data with the model train line. So in order to do that, we're going to use this one here, and we're going to rerun it at the end, but this time we're going to use this here in order to save it because we're going to use it. So we're going to save it here, and the name that we're going to use in order to save it is going to be um, model pick, and like always in FBG format, FBG. All right, so let's see. Okay, we have it here, and model pick SVG. Okay, we are good to go. We have it right now. Okay, so now that we finish with our project, let's change the name here and let's call it edges versus height 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 um, 1. So, and let's save it. So now that we have it here, so we're gonna use some of these files in here, but first of all, we're going to go and do our project in Python. So let's create a project. I will create it in uh, machine projects, and then in here let's make a directory. Dir let's call it edges versus height. Height. Okay, and let's work in Visual Code Studio there. Alright, so we have our project over here. So I will do like a setup that I have when I work with my Flutter projects. I do develop mobile apps using Flutter and Firebase. Um, I I was watching a tutorial the other day about a setup in order to have like Flask and also a database in the project. So I like it, and that's what I going to do right now. Okay, first of all, what we're going to use, we're going to open our terminal here, and then we're going to create our environment, which is going to be pip environment shell. It's creating our environment. Alright, so let's clear. Alright, after that I will go to my view, command palette, select interpreter, and I will use this one here. Okay, so having that, I will install Flash in my in this local environment that I creating. flask again, clear. um like I said before, I like to work with my local database, like my environment database, and for that we're not going to use it uh, real in this project, but just to have it. So it's going to be pip install, it's going to be flask sql alchemy. Here, and also we are going to pip install mm, flask marshmallow here, and then we are going to pip install marshmallow sql alchemy. All right, so now we have to do let's code here a little bit. Okay, the first thing that we're gonna do, we are going to create here our main file here. So it's gonna be main Python file, and in here we're going to start like we're going to start like setting up or importing the thing that we need to. So starting with flask from flask import flask, and from here we're going to use requests, and we're going to use something uh, that is called render template here. We are going to also import this, import sq. All right, and then from flask marshmallow I will import. Okay, all this thing is for my local database. Import os. All right, so in order to run flask, we're going to call it here name, and we're gonna have like the path for our database thing, which I'm going just to paste, copy and paste here. I use this for all my projects. Uh, so the database is going to be equal to SQL Kenny app is going to be equal to app. That's going to be our app, and also then okay, so something else is like my marshmallow. So marshmallow, it's gonna be marshmallow, and again it's going to be the app. It's gonna be the app, right? And then in order this to run, I'm gonna say like um, if name, which is my flask, if name, which is that I have here, is equal to main, so run the app, run. So it's gonna be the book true, and it's gonna be my local port, which is this one, 5,000. All right, so when we have this, like this is like the basic. In here I'm not showing anything yet, so in here we still have to run, to install a little things. So Python, all right, so we're gonna say from main import database. Look this, so far I just got main file and pipe file. So okay, now I will say from main import database again, and import app and database. And now I'm going to say this app, the app context database create all. Okay, exit. All right, so let's try to test this one here. Okay, so if we want to check it, so to see if it's working or not, we can do this, like we can like run it in here. So we can run like app route, then it's going to be in the same path as we have. We are going to use, so far the methods are gonna be just in here. We have to put like the list of methods, like get, post, delete, put, but so far we're gonna get just post because it's the only one we're gonna use. And then we are going to route Then we're going to create a function here, which is going to be, let's call it home. Okay, home, and we're going to return something like a JSON dictionary. In order to do that, we have to here JSON, call also this, because we're gonna need it here for our test. So JSON knife, and then we are going to create our dictionary, and we're gonna say name is equal to 1, and then message is gonna be is working. All right, so with this one, if we run this one, let's see if it's working. Run simple, go down expected keyword. Okay, so here we have a typo here, so it's not the bub but the bug. Okay, now it's running. You can see that it's running here, and let's see if it's working. So you can see it's working, message is working, and name Juan. So we are good to go. We already set up our Flask environment in order to have a local web page that is working under the method get. So we're good to go. All right. So now that we check that it's working, so let's Control C in order to stop our machine, and then we're going to go to our colab, and we're going to download everything that we're going to use for our project. So first of all, we're going to use our model pic. So we're going to download this file. We're going to use our model.joblib. We are going to download it, and we are going to use our data, which is this one. So those are the three things that we're going to use in here so far. So yeah, okay, so now that we have, let's put to finders here, and I don't like to put the files directly in my Visual Studio environment, because it's easier for me doing it in here. So basically I will have two finders here. In one I got downloads, so this is the three things that I just download, and in here we're going to look for the project, which is in here, age versus weight. Yeah, this is the one. So basically we are going to do it in this way. We are going to create a directory here. Let's say if we can do it in here. Okay, let's create a directory in here, which is gonna call templates, and we are going to call another one which is going to be static. um, Move to trash. What happened here? Templates. Okay, we got just template here. Okay, templates, and then in here I will create another one which is going to be static. In static we are going to put all the images. So this one, which is a picture, we're going to put it in static. Here in static. This model, we're going to put it the model in this level. Okay, so I'm also, this one is gonna be in this level also. Alright, so we have a template here, templates without nothing. We have our model here, and we have our picture here, so we are good to go. Alright, so in templates we're going to add a file. In template we're going to add a file which is gonna be our index HTML. In here we are going to have basically this is what we are going to have there. So basically we're gonna have a center, we're gonna have an image, that image is gonna be CRC, and we're gonna give it a value. It's not gonna be static. We're gonna call it href, and this image is going to be a height, sorry about that, it's gonna be a height of 600, and we're gonna close it here. And also it's gonna have a form. The form is this one. We're gonna have a form, and that form is gonna have the method post, right? And I think we can, okay, and okay, we are opening the form here and we're closing the form here, and we can say like it's gonna have a label, and let me copy this one here. Okay, so basically is we did just this one here. This is something missing here. There is something that is not right. Let me figure out what is not right here. Okay, this image and form. Okay, so I'm not an expert in in web developing. In web developing, I do more like I have done projects in web for web that's using Flutter, not HTML. But anyway, we have something simple here, like just as an exercise. So we have the image here, which is going to be a variable as a reference. It's going to be a height of 600. We have a form here, which is going to be this form over here. The method of that form is post. We have a label, which is input a comma separate list of h values, which is this label here. Then we have an input in way of text, which is this one. And then we have a button to submit this input here. So the index HTML, we're ready to go with that one. All right. After this, what we're gonna do is like we are going to go to our main project, and in here we're going to go to our colab, Google Colab file, and we're going to get these functions that we create there, and we're going to have it just right here. Let's have it here. So this is going to be the first one. So we got this definition here, and basically it's telling me that I have to import pandas. So let's do that. Pim install pandas. We're trying to solve this one. So it's telling me that so basically we're going to import pandas and numpy also. So this is the setup, machine learning setup. Let's put here. So it's gonna be okay. So the first one, panda, is alright, and numpy is also there. So now this px, which is this px, which is this one, we're going to import these two. So let's import those ones. So I have to import plotly. So pip install plotly. Let's say if it's gonna work. Okay, it's working. So with those two, with plotly, we are going to do these ones. So looks like we're gonna be ready to go. All right. So okay. Plotly it's still installing. Okay, so it's installed already. Okay. All right. Now we are going to use. Let's see what else we have to from here. Oh, we also have to install this one here. Pip install colab. So we're gonna pip install colab. Okay. When we get that, we are going to go and get the other function. The one that is going to check the strings is this one. We're gonna put it here after, just right after this function. All right. So now that we have everything, looks like we have everything. Let me check. So we have numpy, we have pandas, SPD, we have numpy, we have, okay, we have to import two modes. First of all, the one that is going to allow us to use our model here, that's going to be import job lib as from job lib import load, and let's clear this one here, and let's pip install job lib. Okay, and then we're gonna use something that is called, this is for, because we are going to generate like a lot of pictures. So this one here, which is UUID, is in order to generate like random ID strings in order to name our pictures, right? So everything looks fine over here. Now we're going to replace this one here. So in order to replace this, I will just copy and paste because this video is taking long. So basically here, now before to try them, I was using the method just get, right? But in here I will use post because in order to do this, and because what they're gonna do is like I will put a string of numbers here, and then I will to request something. In order to do that, I need to use the method post. So that's why I haven't get and post here. So in here I haven't like request type string, which is the request method in order to use post. This is the one that I'm gonna use in order to check if what kind of I mean, that's the one that I'm going to check. That's the one that I'm going to use in order to realize if I'm going to do get or post. So basically, if the request is get, that means that it's going to get the image, which is this one. But if it's not, it's because it's post, because it's the only thing that I have available different to get. So if it's get, I will tell her like to return a render template. That means that as a H reference is going to use this image, that is in this folder, which is static, and the name, actually let's copy relative path here and let's replace it here. All right. So basically, I'm telling that as soon as I open, if I use the get method, it's going to show me this image. But if I'm not using get, but post, that is the other option that I have, so then it's going to call this function, which is make picture, which is this function here. But in order to do this function, I need four parameters, which is the training data file name, the model, the new input, and the output file name. So in order to give it that to my function, I can say like test is gonna be the one that comes from the request form, which is the form that I got here, right? So this text, this is gonna be the text, right? So, but the first parameter that I need is the training data file name. So the training data file name is gonna be this one, which is this one, is where I have the data. Then the model is gonna be it's gonna be, I'm using the function load from joblib, this one here. So I'm telling it to load this model that I downloaded from my Google Colab project, right? Then I need also the new input MPRI. So what I do here is like this new input MPRI is gonna be to the to this text that is going to be the one that the user is going to input in the form. But remember that that text is in a string way, and I have to convert it. So for that, I'm gonna use this method here that we create, which is float string to MPRI, because is the format, the way that we need in order to get it into our model. And this random string is in order to name our pictures, and then the output file name, which is going to be the picture, because remember that the output is going to be something like this, and this is not Jupyter Notebook, it's not Google Colab Notebook, this is an image. So in order to create this image, I have to name it. So I use uuid dot uuid4 parentheses dot x in order to create a random string every time I call this function. So it's going to create a random name for that file, because if I get like the same name, so the cache of the browser is going to keep showing me the same image over and over again. That's why I have to use different names. So, and then I just call the function here and I return the render template. That render template that I returned is going to be in the index HTML, which is this one. That's the thing that is going to render, and is going to have as a h reference the output file name, because remember that in the index I have here as an image a variable which is h reference. That h reference is this one, which is going to be the result of this function make picture. Okay, so I believe that's gonna be all. Let's run it and see what happened. All right, okay. Okay, took a little while in order to do it. I was scared for a while. Okay, so it's running properly. Let's see if it's working. Let's take this out of here and let's do it from the beginning. Alright, I have my model here, and then if I give it, if I ask it to give me like the prediction for 4, 6, 10.5, let's say this is a blank space, an error, and then I could 4.8, let's see what happened. So, okay, no model name skill learn. So let's Control C and let me how I can call. I have to pip install skill learn because that's the thing that is telling me here. Alright, so let's install using pip install ACI kit learn. Okay, it's gonna take a while. Alright, so looks like finished. Let's run it again. Okay. Okay. Alright, so this one was the one that we was trying. Okay, it's thinking, it's running the model in the back. And because it's the first time, sometimes when it's the first time, take a little while to run it, but at least it's not showing us an error right away like before. So let's see what is happening here. Okay, all right, it's showing, it's working. It's showing for 4, for 4.8, 6, 10.5. Are those the one that we will? Oh yeah, this one. Those are the ones that we were looking for. So let's try just 1, 9. So if the age is 9, the prediction is going to be 47 in the height. So in this way, we convert something that we develop in our Google Colab, very simple, into something that is more likely, is more that to be used in real world, like this one here. So because what I think about machine learning or developing models is like create tools to a stakeholder, so that person can use something really simple like this one. Okay, thank you very much for your time and see you in other occasion.